I'd like to welcome Victor from Starkware. Thank you very much.
Okay. Get my house keys, they go over here. Okay, so today I'm going to talk about bidding on Starknet. For those who don't know, actually, who knows what Starknet is? Raise your hand. Okay. Are there any Solidity developers in the room? Any Rust developers? Yeah, all right. Then today I'm going to talk about building on Starknet. That's the agenda. It's what the heck is Starknet and how does it work. I'm going to introduce you to smart contracts on Starknet because they're a tad different to the other L2s. And then how to make money by contributing. So what the heck is Starknet? Essentially, we have a big problem if we disregard blockchains completely. If things are centralized, then you have this really big server. Let's say Google is a really big server. Things are centralized at Google. You push events at Google, and it basically all goes through this one big server. And this is not really cool, because if this server goes down, then these people are not really happy. And so the solution is this blockchain idea where these multiple people all run this big server, but in a smaller format, and they can all run it like on their computer. However, what we see with a lot of the problem with Ethereum is that the block space to run a node is quite limited. And so what you see with these alternative or EVM killers is that to make it more performant, to make it faster as a blockchain, what they do is that they increase the block size of their network. And so if you start increasing the block space, then people who are, people just like you and me, we can't really, if we have a standard computer, we can't really run a node anymore because it's too computationally demanding. And so Ethereum stays with this bounded or limited block space, and which is also why it's quite slow still and not that performant. And so the solution is to build on top of Ethereum. It's to do like an L2. And what an L2 essentially does is that multiple people send requests to the server on this L2, and then this information is processed or is delivered to Ethereum. The whole goal of an L2 is to tell people, hey, this amount of work is not going to be done on Ethereum, it's going to be done elsewhere, and what I need to do to tell Ethereum that this amount of work actually happened on this other space, I'm going to create a proof of integrity. I'm going to prove that what happened elsewhere is correct. And then Ethereum doesn't have to do the whole work. And so essentially what we send to Ethereum is sort of like a balance sheet. It's kind of a summary of all the transactions that happened. And you have multiple transactions that essentially get processed by a prover. A proof is sent to a verifier. And this verifier, we actually have a verifier written in Cairo right now, which is the programming language from Starknet. And this Cairo verifier allows you to build app chains, and which are layer 3s that are built on top of layer 2, but I'll get into that in a bit. But essentially, this is how Starknet works. This is how L2s actually work in general. You have a proof, and then this proof is actually sent to a verifier on Ethereum. And this is why we scale Ethereum. It's because Ethereum only has to verify this proof that says, hey, all of this stuff happened elsewhere. And if we look at Starknet, what it can do is that one block fits around 1,800,000 NFTs. That's just to give you an idea of the performance. So essentially, we're scaling blockchains. We're scaling Ethereum with Starks. And this is what Starknet is. Essentially, this is kind of an overview of how the Stark proof system works. But in this L2, this is where the Stark magic happens. It's in this proof generation, and this is the proof that compresses all the stuff that happened on Starknet and proves to Ethereum what happened elsewhere is correct. And I was talking about layer 3s around 2 minutes ago, but essentially layer 3, if we think of an L2, what it does to an L1, a layer 3 like, how do I say this? An L2, wait, it's quite complex because L2 is L3 is. An L2, an L3 does what it does to L, wait, it's so confusing. Okay, essentially the big TLDR is that if you have a prover and a verifier that is on the L2, then you can create an L3. And essentially you're scaling even more. How you scale from the L2 to the L1 is even more scaling than what you do from the L3 to the L2. And then you have Cairo. So who here has heard about Cairo? Okay, nice. Cairo is the smart contract language for Starknet. Solidity is the smart contract language for Ethereum, but also other L2s like zkSync or Scroll. Now, why do we have a new programming language? Why didn't we just go with Solidity? The reason is because Solidity is nice, but it wasn't built, or the ETHDam wasn't built for provability, for generating proofs. And so we told ourselves, hey, what if we just go with a programming language that's specifically designed to generate proofs? A programming language that is just for creating zk programs. And essentially, what we're doing with the ETHDam is that we're not reaching for ETHDam compatibility, we're trying to reinvent Ethereum. If we were to go with ETHDam compatibility, then we would have gone with Solidity. And Ethereum was not built for provability, so that's why we essentially built the Cairo VM and Cairo as a language. And some things that make Starknet cool is that we have native account abstraction, so you can build really like user-friendly applications in like quite easily. We have high throughput and transactions, and the devs usually come for the tech, but they stay for the community. And we have a couple of Starknet devs over here. So now smart contracts. Cairo, what it does essentially, so it's this program that is Rust-like. Who are the Rust programmers in the room again? Okay, nice. Cairo is actually kind of forces you to write safe code, and it forces you to kind of innovate your program, just the way it's structured and the way it's written out. And what is Sierra Chasm is what Cairo compiles to, and Sierra is like this intermediate layer that makes sure that all the program that you're writing is actually provable. And so we have this. I'm going to go over some concepts about Cairo smart contracts. You usually have a contract class and a contract instance. A contract class is the code itself. It's essentially it creates a class hash. And a class hash is like, you could see it as a definition of your smart contract. And every time you change something in your smart contract, this class hash changes. And then we have a contract instance. And that's when you deploy, you first have to declare your class hash, and then you deploy a contract. And then you have an instance. And what this instance basically does is that, hey, it tells you the storage on this smart contract change. And if the storage changes, then essentially then the contract address also has to change. And overall, this is a little diagram that just summarizes what I just said. But the Starknet state is composed of contract classes. And within the contract classes, then you have these instances. And how do you change the state of Starknet? You essentially have two functionalities. It's to read your smart contract, and then you can also write. And when you write something, that usually entails paying gas fees because you're changing the state of your smart contract. Yeah, so you have declare, invoke, and deploy accounts, and those all they all cost gas fees. All right, and some quick anatomy of a Cairo smart contract. For the Rust devs in the room, maybe you'll recognize a couple of things. But essentially, in a Cairo smart contract, the way it works is that you neatly define all the components within your smart contract. You neatly define your storage, what goes into your storage, and the variable type that goes into your storage. So this is, for instance, this is the storage attribute. You always have to create a module and then give a name to your smart contract. and then you define the storage. And let's say that my value is a felt 252. And then you also have a constructor attribute. And what this does is it tells the compiler, hey, this is the first values that are going to be the ones once I kind of declare this smart contract. Then we also have events. And the way we expose functions is that you always define an interface in your smart contract. And an interface is kind of like a blueprint of the functions. And then within the contract module, you specify what you're going to do with those functions that you define in the blueprint. So in Rust, there's this, you define a trait and then you do an implementation of this trait. So it's very, very similar to Rust. And this is the interface that I just talked about. And this is how you expose functions. Essentially, it's the trait and impl combination, just like in Rust. Any people familiar with Solana in the room, or have ever done something on Solana? Traded? Did anyone build on Solana? Okay, because Solana also has their smart contracts written in Rust, but it's in general we see some similarities. And then if you want to call certain functions from another contract somewhere else, you essentially use something that's called a dispatcher. A dispatcher is always generated when you create your interface. Let's say they have two smart contracts. I have one storage smart contract and one contract that increments a number. The contract that increments the number will always do a call from the dispatcher from the storage contract. So it's going to, you have to use this dispatcher keyword and just basically say, hey, I'm about to use your function in order to change things inside this smart contract. And now maybe something that's life-changing for some of you, at least for some people in the front row. It's how to make money by contributing on Starknet. And there's this really neat website called OnlyDust. Oops. OnlyDust is essentially, it's a platform where you have projects that are listed, and then these projects, they tell you which issues should be solved. And then as you solve each issue, you basically start earning money. And so I want to quickly run you through a couple of projects, and then also show you how you can get started on it. So if I go to the app, for instance, if I'm within the Starknet ecosystem, there's this open source sequencer called Madara. If I click on Madara, you actually see all the people who contributed. If you click over here, and then if you go over to the GitHub repo and you solve an issue, then you start making money. And we have some people who used OnlyDust in the room, especially in the front row. So if you have any questions on how to get started on OnlyDust, just ask them some questions. And yeah, you can make quite some money. Going back to the presentation, where is it? Oh, it's in the same browser. And yeah, just an overview of the developer ecosystem. Starknet is right over here. There's quite some growth in the last year, especially with the change from Cairo 0 to Cairo 1. And Cairo 1 is this Rust-like syntax type of Cairo. Cairo 0 used to be this legacy language that was very hard to build programs with. It was quite a difficult syntax. But ever since the update to Cairo 1, which is essentially this Rust-like syntax language, we've seen a growth in developers, a growth in terms of toolings as well, and libraries. So in general, it's in the green. And yeah, if you want to get onboarded on Starknet, just come over and talk to me. I'll introduce you to a couple of group chats, to people, to educational content. This is me on Twitter, this is me on Telegram. And yeah, thank you.
Hi, thank you for the presentation. And I just have a couple of questions here. So what's the underlying VM for Cairo that, underlying VM that Cairo is executed by once compiled, I guess. And then I remember you were announcing that like the original sequencer was supposed to be rewritten in Rust. If that happened, and if there are further plans to, leverage any decentralized shared sequencer kind of technology. And also, did you make use of blobs?
So first question, we use the Cairo VM. We don't use the EVM. We cannot use the EVM because we have our own.
Yeah,
language.
I meant the VM. Yeah, sorry.
Yeah, so we were using the Cairo VM. What was your second question?
The next question was about the sequencer.
Oh, the sequencer. It's rewritten in Rust. There was an update last summer, and there was a boost in TPS.
And any plans for leveraging shared sequencer later for decentralized?
In order to decentralize, yes, it's on the. We're thinking about it. Yeah.
Okay. And have you made use of blobs? And if there's I'm not sure, is the DA layer used on Ethereum used as a DA? And
Yes.
settlement?
So it's just like any other rollup. We use Ethereum to settle. We used blobs. I think I don't know if zkSync or we were the first ones to implement. We were the first ones? Okay, then we were the first ones to implement blobs. Yeah, there's a chart with all the L2s, and there's a little line that goes boop, super down with all the fees. And we're one of those lines.
Awesome, thank you.
Any final questions? All right, one last round of applause. Thank you very much.
Thank you.